Radiation. Source. The Sun emits a broad spectrum of electromagnetic radiation due to nuclear fusion at its core. Surface temperature. At approximately 5,500 degrees Celsius, or 9,932 degrees Fahrenheit, the Sun's surface generates a wide range of electromagnetic radiation. Relationship with temperature. Radiation range. The temperature of an object like the Sun doesn't directly define the range of electromagnetic radiation. Instead, temperature and composition influence the spectrum emitted. Spectroscopy. Techniques such as spectroscopy are used to study the specific In the third part of your guide, the conversation continues to explore the relationship between the Sun's radiation, including visible light and other electromagnetic waves like ultraviolet radiations and X-rays, and other phenomena like nuclear explosions and their auditory impact. Let's break down the key elements. AHER, Sun's radiation and its properties. Photosphere, the visible layer of the Sun that emits light, with a temperature of about 5,500 degrees Celsius, or 9,932 degrees Fahrenheit, capable of generating a broad spectrum of electromagnetic radiation. Electromagnetic radiation and temperature. Range of radiation. While the temperature of the Sun is indicative of its ability to emit a wide range of electromagnetic radiation, it doesn't prescribe a specific frequency range. Spectrum analysis. The specific radiation emitted, known as a spectrum, can be analyzed using spectroscopy to reveal details about the object's composition and conditions. Power output of the Sun versus nuclear explosions. Energy comparison. The Sun's output. The fourth part of the document seems to delve into the intricacies of sound and light, their behavior in different mediums, and the vast energy output of the Sun compared to nuclear explosions. Sound and light in different mediums. Refraction. This section explains how light and sound waves refract or bend as they pass through different mediums like air and water due to changes in speed. Behavior in water. Both light and sound travel differently in water than in air, with light slowing down and bending, and sound traveling faster and further in water. The Sun's radiation. Spectrum of sunbeams. The Sun emits a wide range of electromagnetic radiation, including visible light, UV radiation, X. In the fifth part of the document, the discussion explores the topic of loudness and intensity, specifically in relation to nuclear explosions and the Sun's energy output. Here is an analysis of the content. Sound intensity of nuclear explosions. Nuclear explosions can be incredibly loud, with a sound intensity of up to 210 decibels, dB, far exceeding the human threshold for pain and potential hearing damage. The Sun's auditory presence. It is clarified that the Sun, despite its immense energy, does not produce sound in the conventional sense, as it does not travel through a medium like air or water. Inappropriate comparisons. The text discusses the inappropriateness of comparing the loudness of nuclear explosions to the Sun's power output, as they are measured in entirely different units and represent distinct phenomena. Theoretical. The sixth part of the document continues the conversation between Marcy C. and the AI regarding the comparison of various physical phenomena, including the relationship between sound and electromagnetic radiation, specifically the Sun's energy output versus the loudness of nuclear explosions. Visible light and sunbeam composition. The discussion reaffirms that visible light falls within a frequency range of about 400 to 700 terahertz. Sunbeams consist of a broad range of electromagnetic radiation, including visible light, infrared, ultraviolet radiation, and other waves. The Sun's energy in nuclear explosions. The Sun's immense energy produced. The seventh part of the document delves into the discussion about the inappropriateness of comparing the power output of the Sun with the loudness of a nuclear explosion. The conversation continues to clarify the reasons why such comparisons are not meaningful and do not provide useful information. Key points. The power output of the Sun and the loudness of a nuclear explosion are unrelated and measured in different units. The power output of the Sun is an immense. The most important information from the eighth part of the document can be distilled into several key points that highlight the nature of nuclear explosions and the immense power of the Sun. 1. Intensity of nuclear explosions. Nuclear explosions can reach sound intensities up to 210 dB, significantly above the human threshold for pain and potential hearing damage, which is around 120 dBs. This level of sound intensity can not only cause irreversible hearing loss, but can also be outright lethal due to its high energy impact. The sun's power output. The sun is described as an extremely powerful and luminous celestial object that serves as the primary energy source for the solar system. Its energy comes from the process of nuclear fusion occurring in its core, where hydrogen nuclei combine under immense pressure and high temperatures to form helium, releasing vast amounts of energy in the process. The total power output of the sun is estimated to be about 386 billion megawatts, MW, illustrating the incredible scale of energy produced by our closest star. This is orders of magnitude greater than any human-made explosion or energy source on Earth. Number 3. Comparative perspective. The document points out the inappropriateness of comparing the loudness of nuclear explosions to the energy output of the sun. Such comparisons are not meaningful due to the fundamentally different natures and scales of these phenomena. The sun's energy production through nuclear fusion is a continuous cosmic-scale process that sustains life on Earth, while a nuclear explosion is a brief, destructive event with localized effects. Number 4. Goal of making AI more natural and safe. The section closes with a reminder of the overarching goal to make AI systems like ChatGPT more natural in interaction and safe for users, underlining the importance of feedback in improving these technologies. These points collectively emphasize the extraordinary energy dynamics in natural stellar phenomena compared to human-made events and the ongoing efforts to enhance AI interaction and safety.